Hello everyone, Mr. Hissner here, and today we are going to start a new topic on trapezoids. But before we do, I just want to say that this week is going to be a short week, both in length. We have Tuesday through Friday, and also because Tuesday and Wednesday we have a half-day schedule. So for those of us on Wednesday, we're only going to be in class for 30 minutes for the whole week. So you need to come to class on Wednesday ready to learn things, and you need to put in a little bit of extra work in this distance learning asynchronous format. So just know that going into this. So we're going to be looking at trapezoids, and last time we did our last topic on parallelograms and stuff, I said it's a good time for you to kind of brush up on your transversal skills, and one of the reasons is because these parallel lines and things, they just never sort of go away. So when we look at trapezoids, we have two parallel lines right here and a transversal here. And so we know that angles 1 and 2 are supplementary. We have two parallel lines again, and then this transversal. And so we would know that angles 3 and 4 are supplementary. Just remember that consecutive angles between parallel lines are supplementary because they are consecutive interior angles. We also have the ability to have isosceles triangles, or trapezoids rather. Isosceles means that isosceles means that the sides are the same, the legs, right? So here's our two parallel lines, and then our legs here are the same. But what we see with isosceles figures, just in general, is that if the sides are the same, if the legs are the same, then the base angles are the same, and that's what we see here. Also, we know that these diagonals are congruent in these isosceles figures, and opposite angles are supplementary. Opposite angles are supplementary. So, well, duh, because if you have 1, 2, 3, and 4, we know that the measure of angle 1 plus the measure of angle 2 is equal to 180. Well, guess what? The measure of angle 1 and the measure of angle 4 are the same. So we know that measure of angle 1 is equal to measure of angle 4, and so we can make a substitution, and then we can conclude that the measure of angle 4 plus the measure of angle 2 is also equal to 180. So just a kind of heads up and a remembrance of years of lessons past. So let's look at this first figure. This is a non-isosceles triangle. These lines are parallel, and that means that this is a transversal, and also that this is a transversal. And so if I want to find this measure of angle M down here, measure of angle M, all I have to do is say, okay, well, I know that these two angles add up to 180, and thus I can just take 180 minus 87, and this one is going to be 93. And also then I can look at these two angles and say, okay, these are consecutive interior angles, so they add up to 180, and so I can take 180 minus 51, and that is 129ers. And so, yep, 129, and this one is 93. And again, these consecutive interior angles add up to 180. Really nothing to it, nothing to it. And again, we've been doing this since September, and that last section we had on what are these things called? Polygons. Kind of warmed us up to this idea. So let us look at this next example. Now, if we can see the difference here, this is algebra, but again, the principle is the same. So notice here that we have a transversal cutting two parallel lines, and thus these are consecutive interior angles. And so measure of angle 1 plus measure of angle 2 is going to add up to, measure of angle 1 plus the measure of angle 2 is going to add up to 180. And so measure of angle 1 on the left there is 54, plus the measure of angle 2 is 8x plus 6, and that is 180. And we can simply combine like terms and then subtract that from both sides, and we get 8x is equal to 120. Divide both sides by 8, and we find x is equal to 15, and just stop here and think to yourself, am I done, right? Is this the end of the problem? And for us, yes, we are done. So we can put a little stop sign there. But for others, you'll notice you must continue. All right, let's look at an isosceles figure. I'm just going to pick one down here. These isosceles figures, how do I know that this is isosceles? Take a second, pause and ponder. How I know this is isosceles is because we have these two hash marks indicating that these two legs are the same length. If a figure is isosceles, then the base angles are congruent, and so I have these base angles that are congruent down here, so if I want to find out the measure of these base angles, or really any angle, I just have to consider that this is the transversal region. These are two parallel lines cut by a transversal, and so I can simply say, okay, well, that means that the interior sum of these consecutive interior angles, they have to be supplementary, so I can just subtract the one from the total, and we find that this is something with an 868. Measure of angle S, 68, and you'll notice that the measure of angle S is a base angle, measure of angle R is a base angle, so these two angles are the same when we have isosceles figures. Isosceles figures have two congruent legs and two congruent base angles. And then finally, we would know that the measure of angle Q up here actually is also going to be 112 because these two angles, these are also kind of base angles, and in fact, if I could flip this figure, you could see that if it were upside down, the base would change. PQ would now be the base, and thus those would be the same. Now, overall, I think you will find that these figures shouldn't give you much of a problem. Thanks for watching, guys.